Hello everyone, my name is Neil Robinson, Product Marketing Director for Tensilica Products. This is the second in the two-part series of Whiteboard Wednesdays on SSD controllers. Last week we talked about the basics and also the trends of SSD controllers. And this week we're going to talk about how Tensilica processors are being used for SSD controller to meet those trends in the industry. One of the biggest requirements that we had, the biggest trend, was high performance and low energy consumption. Now, really the only way you can do that is by reducing the cycles required for all of the processing that's happening between the host and the flash itself. Now, the obvious way to do that might be to offload that with RTL. And that works, you get a very high performance and low energy, but you do have to have more time spent developing it and also verifying it. And in addition, you're reducing the amount of flexibility that you have because it's less programmable. One of the benefits with using Tensilica processors is that you can actually add new instructions and I/O to the processor. So rather than offload to an external piece of RTL, you can build that functionality into the processor. You're effectively adding the same data path, but all of the state machine logic becomes part of the software itself and the programming of that. One of the benefits that you get from using our system is actually all of the processor that's generated is pre-verified for you. So no matter what instructions or I/O you add, the actual processor delivered to you is pre-verified by Tensilica for that. So you don't need to do it yourself. And also, all of the software that you require for your development is generated automatically. Again, no matter what instructions or I/O you add, all of the compiler, the instruction set simulator, the debugger, all understand the new instructions that you've added. And finally here, we have, because of the architecture of the Tensilica processor, you actually get a very high level of parallelism. What that means is that because you have a VLIW architecture, you can actually issue multiple operations in one cycle. So multiple operations, multiple arithmetic operations, and also access to multiple I/O all in one cycle. So some of the benefits that you get by using this approach is you do meet the high performance and the low energy requirements that are trending in the industry because we're able to reduce the cycles just like offloading in RTL, but we build them in as instructions into the processor. And then because of the high level of parallelism available, you actually get that the solution is very RTL-like. You get very similar performance and energy profiles as you would with an offload of RTL. In addition, because you're actually using the tools that we supply, you actually get a much quicker development cycle and iteration cycle, which leads you to much lower risk in that approach. Remember that you're not having to re-verify all of the logic that you created because that's all pre-verified by us. Also, you have much higher simulation speed. You're running this at instruction set level to begin with, cycle accurate. So this leads to a much lower risk approach to developing this new logic. And then because of the generation of all the software automatically for you, you retain programmability. Whereas with an RTL offload, you're limited in flexibility. Now you retain the programmability that you originally had because all we've done is added instructions and I/O to the processor, which means you can make adjustments right up to tape out and even after tape out. Because sometimes the specifications on the host interface and the flash interface can change at any time. So it gives you much more flexibility. For some actual examples of the types of algorithms that our customers use in SSDs, take a look at our website at ip.cadence.com/storage. There you'll see some examples of 6 algorithms that are commonly used, and you'll see that we've added a very few number of gates for a very big performance and energy reduction. Thank you very much for watching. Bye-bye.